Okay, this is where I ended last time about why it was important. So, valence electrons and chemical bonds. Valence electrons are the outermost electrons. Okay? The number of the group determines how many valence electrons it has. That's why we folded our periodic table. Valence electrons are the means in which a chemical bond can be achieved. Chemical bonding is a process by which atoms combine to form molecules, and only the valence electrons take part in this. So only the outside ones, not the ones shielded on the inside. Chemical bonding is the exchange or sharing of one or more electrons between atoms which unite in a chemical reaction. So let's look a bit closer at this. A chemical bond is defined as the force or linkage which holds atoms together in molecules or crystals. We have something called van der Waals forces, which are your basic forces. Sometimes they're called London dispersion forces. They're a weak intermolecular force. It's present in everything. Okay? You are expected to know van der Waals forces or London dispersion forces. You can also have electrostatic, which is the attraction of opposites attracting one another. Just like if you had a Van de Graaff machine and you brought your finger close to it and you had a shock between the finger and the top of the Van de Graaff, that would be an opposite. That's why lightning strikes. It can also be dipole. And a dipole is attractive force between a positive and negative end of a molecule. Water is known about this. Water has dipole forces going on because of its negative oxygen molecule and its positive hydrogen molecules. And this is water, the Mickey Mouse. Main types of bonding. There are three main types of bonding. We first deal with ionic and covalent. Metallic is simply that the valence electrons are held loosely in the inner parts of the atom. They're free to move within the metallic crystal, which is why metals generally conduct electricity, they conduct heat, because those electrons can move from place to place. Okay? We don't deal much with metallic bonding. Okay? But that's the reason it has those properties there, including ductility, malleability, conductivity. Okay? Malleability means to be able to force into the shape of a sheet, and ductility means to place and to make wires out of. Covalent bonding is a sharing of electrons. Okay? That was a group of cards that had the prefixes on them, had all the non-metals in there. Okay? And there's a reason that they share electrons. Ionic bonding is different because ionic is a gain and loss of electrons, and we'll use the crisscross method on that. We will go back to the Lewis dot. You are expected to represent your elements with the Lewis dot and to show the bondage that occurs between them. Ionic bonds. Atoms may join by the process of losing and gaining of electrons, which is why I had you write on your periodic table when we wrote group 1, we wrote +1, group 2, +2, group 3, +3. Because groups 1, 2, and 3 generally lose electrons because it's easier to lose electrons, up to 3 of them, than it is to gain 7, 6, or 5. Okay? It's a give and take relationship. These are chemically active atoms. They have a strong tendency to form the stable electron configuration in the noble gases. They have strong bonds, and we'll see that in one of our labs. They want 8 electrons. They want an octet. And we went through this already. Alkaline metals lose 1 electron, so they get a +1 charge. Alkaline earth metals lose 2 electrons, +2. Boron family lose 3 electrons, +3. Okay? Please remember that whenever I lose electrons, I'm losing a negative charge, and so I gain on the positive. I don't change my number of protons in that atom because a proton determines who it is. It just means I have more protons than I do electrons. I'm no longer at ground state. Groups 5, 6, and 7. Group 5 will gain 3 electrons and take up a negative 3 charge. An oxygen family gains 2 electrons minus 2 charge. Halogens gain 1 electron minus 1. Noble gases are inert. They do not form bonds. They are monatomic. Everyone else is trying to get 8 valence electrons or a full octet. Okay, so here's the symbolism of it. Here I have my sodium atom and here I have my chlorine atom. And so sodium is going to give up this 1 electron in the outside shell to chlorine, who needs one right here. And I will have a bond that forms right here. Okay? Another way of looking at it is with my Lewis dot structure. Again, this one gives to the chlorine to make a bond. And so when I draw these, I end up with basically Na dot, and then chlorine is here. And this represents a bond. Okay? I could have also drawn it like this with a line also. Okay, please note that sodium chloride is not a single particle. When you're dealing with ionics, you'll be dealing with crystalline forms. You basically have the atoms. So here's my chlorine, here's my sodium atom. You have them stacked up on themselves into a regular formation or a crystal formation. So we say NaCl, but it's a whole lot of them to make up the salt that you can see. And sodium chloride is cubic. We know that. Ions. When atoms gain or lose electrons, they're called ions. Here's some vocab that you need to know. Cations are positively charged. The way to remember that is if you write cations, there's a T right here, positive charge. Anions are negative charged. They're going to be groups 5, 6, and 7. Okay? This is vocab words you need to know. Since there is a charge, we can say they're electrified particles. Remember the electrolysis lab? We added salt to the substance in order to get it to conduct electricity, in order to split the water. Okay? Crystalline structures are called particles and not molecules. Ionic bond. So an ionic bond forms between one metal and one nonmetal, or one cation and one anion. Okay? There are some exceptions to it. And in the next video, I'll talk about how to do the crisscross method. Thank you. Have a great day.